Alright, for port 3, now that we got our puck pressed onto our shaft, this is the part we will end up grabbing in the chuck, and this is the part we will be turning down to fit into this hole, just a nice slide fit in this hole in the brake rotor. And just so I can make sure it runs that much truer, I'm going to take the center, jam that in there, and I'll put a little chamfer. This whole piece that I grabbed happened to have this little bit sticking out, which actually ends up working out. I'll put a little chamfer here, and I'll run this center in there and hold it in there in place. And I should still have enough room to come in with my turning tool in here and machine away at this surface down to my size. All right, now let's push this heavy tailstock forward. I'll lock it. And now we'll draw it in. And I'll bring you over here. So there's a little chamfer that's machined in there. And if fingers correct, tailstock should just sit nicely right in there. And I have my handle up here. I'm gonna give it a little bit more, because I don't want the handle to, any vibration to actually come back down and loosen up here. Okay, so that's in place. This is locked into position so that this won't shift back. And now, let's see how true it runs. All right, I'd say that's pretty good. You can get to machining. So now we will begin machining towards our slide fit so that the brake rotor can slide right over that fit, and it can slide up against the puck that is pressed fitted onto our mandrel shaft. And again, like I've said in part 2 and maybe even part 1, my turning tool was given to me by one of my coworkers, and I don't have any other replacement tool bits to go into the turning tool. So I'm just taking light cuts, 50 thousandths at a time, just to ensure the longevity of the tool. I can borrow different coworkers' tool if I want, but I try not to do that because he does actual jobs, makes actual shafts and whatnot. And these are just, on the side for these videos. So I'm turning down all the way up to the puck. And because I also don't have a radius tool, you'll see later in the video, once I get the turning tool all the way up against the puck, after I do get to my final slide fit size, I will actually go in to that little corner there, up against the puck. And now I'm gonna mic what I'm currently at. Always measure before you get anywhere near close to your size. I'm currently at 2 839 thousandths of an inch. On my way down at 2 about 735 thousandths of an inch. And plenty of coolant on the tool, or on the material turning down into the tool. But pretty much if you can get the coolant flowing right directly onto the tool, it's probably your best bet. And here the chips are coming off pretty nicely, so as far as chip management goes, I don't have to use the air blower, compressed air on the turning tool to blow out all the chips like crazy, like maybe you would have to do with aluminum perhaps, especially on the milling machine. So it's not that bad here. And I actually machined only part of my final slide fit, only about ½ an inch down or so. And then I actually took the tailstock loose, pulled it back, and then went ahead and tried to test fit my rotor just on that ½ inch part of what I was hoping to be my finished size. And what you're gonna see here is that I'm gonna pick up the rotor and I'm gonna test fit it. I'm gonna wipe down the area on that part of the shaft, make sure it's clean, make sure there's no bits of anything. That way I can get a good test fit. And I'm gonna find that it goes on there, but not quite all the way down that ½ inch part of shaft that I machined down. So once you get down to this really, really close, to your finish size, you're gonna wanna whip out the sandpaper, the emery paper as we call it, And you're gonna have to polish the shaft until you get it just to the right size. But don't go past it. Once you go past it, then you will have to just start over, because if you want to have a good part with what you're working on. So here I am going at it with the emery paper, and I had to cut a lot of footage. It took me a really long time to get to the size that I needed. Lots of polishing to get down to the size I needed. And like I said in part 2, this machine was cutting a very slight taper when I machined the back end of this mandrel shaft down to 2.5 thousandths of an inch, or 2 inches, 2.5 inches pretty much. It was cutting a slight taper, about half of a thousandth of an inch over a 4-inch length of shaft. Which is 0.005 inches. Half of a thousandth of an inch, 0.0005, excuse me. And I'm miking the shaft again, just making sure I'm getting close, and then I actually was able to finally get down to the finished size that I needed for a good slide fit. I did test the mandrel, but here I am now facing the puck, because again, I'm going to leave this whole thing in the chuck of the lathe. So the last thing to do, now that I have my finished size of my mandrel shaft, I'm going to actually go ahead and face the puck. That way, when I slide the brake rotor over the shaft, it can sit up against the puck, and the puck will be faced in true and flat. And then hopefully, when I go to indicate in off the hub face of the brake rotor, it will be running almost true. I can't expect it to be running perfectly true, but as close as I can get it. And this is just a huge important step here, to face the puck of the mandrel I have here. But again, because I don't have a radius tool, I'm actually going slightly in to my finished size of the mandrel shaft, the area right up against, in that corner up against the puck. And once I go slightly in there, I can ensure there won't be a slight raised edge on the mandrel shaft that's up against the puck. And once I go in to the shaft, then I can go also into the puck slightly, and then I can wind the compound out, almost, kind of dragging the tool, if you will, pulling the tool back and letting it cut against the face of the puck as I wind it back out straight. And I'll have to do this a couple times to ensure that I get a full face cut, because what you can listen for is the tool skipping as you slowly wind it out. And when it no longer skips on that last cut, when it's just a consistent cut all the way out, you don't hear any skips when it's cutting, you can be sure that you got your last full face cut and that your mandrel is faced properly. And you see here, I still have a little bit of a bandsaw cut mark, so I have to go again. So I will actually go this time, go in the opposite direction, go in towards the shaft of my mandrel. Again, just taking a light cut, 10 thousandths at the most. This, as my coworker told me, the gauge on the handle is not super accurate, so I later, for the next part of this series, for actually turning the rotors, I had to set up an indicator. So thanks to him for all the things he's shown me over my, this is 6 years now, working at the machine shop. I've only been working on the machines for 4.5 years. You're really not supposed to get on them as a helper, but I was given the go-ahead by my boss, the foreman, which was a huge help. And I enjoy working on the machines. I enjoy learning, so always trying to pick up more knowledge. Okay, so I'm coming in. Hopefully this is the last face cut. It's actually not going to be, because you're going to see when I stop the lathe, there's a very slight amount of a bandsaw cut mark left on the outer area of the puck on the mandrel. And so not pictured, not shown in the video, is me doing the final cut, because either the phone battery was getting low or I had to hurry up and do it because I had to go out on a job with my coworker. And that little last bit right there, I have to take care of one more face cut. So I did that, and then we cut to the rotor, finally a successful test fit onto the shaft of the mandrel up against the puck of the mandrel, and in next video you will actually see me resurfacing the rotors. Stay tuned for that. Thank you for watching part 3. I'll see you in part 4.